Alright, we are here in Logic, and I've got a pretty simple setup here. I've got a ESM that is routed into a ring shifter, which is routed into an EQ so that we can see what's going on. I've got the ring shifter turned off right now, so you can see the basic waveform. I've got this ESM set up with a low cutoff, so it basically looks like a sine wave with a few other harmonics, but not much else going on. And then the ring shifter is you can find it under Modulation ring shifter. This is Logic's plugin to do ring modulation. What are we talking about again? Ring modulation. And I'll just walk really quickly through all the different features of this. So here we've got some stuff that should look familiar and is actually kind of like most of the effects built on top of it and not really totally necessary. But we've got a delay section here, which works the same way as I just did a video on delay, so that should be pretty familiar. We've got a dry-wet output selector, which selects between effect and non-effect. And then we've got the frequency selector, which is going to select the frequency of the modulation signal. Up here, we've actually got several different functions that you can use with this. So this is not just a ring modulator. You can also do what's called a frequency shift, which is similar except it doesn't have the sidebands. When you do that in single mode, it moves both the right and the left channel up in terms of frequency. When you use it in dual mode, it actually moves your right channel up, but your left channel down. So again, you don't get the sidebands, but you get this weird behavior where actually now you have a stereo effect. The OSC selector means that we're going to use the internal oscillator, which is the frequency section here, to create the modulation signal. And then sidechain means that you can actually modulate with any signal generated anywhere in your entire project, and then you would select that up here if you wanted to do that. So let's stick with the basic OSC functionality. The oscillator is basically what I walked through in this video. There's a few other kind of cool things here too. So we can actually change the frequency on the fly with several different inputs. The first is it has a built-in low frequency oscillator, and what this would do is it could actually increase or decrease the frequency that we're modulating with according to this waveform. So you can mess around with that down here and actually change the waveform using these symmetry and smoothing functions. Over here there is an envelope follower, and this is the same concept, except rather than using this low frequency oscillator to change your input frequency, it's going to follow the envelope of your input signal. So when you, for instance, if the signal is really loud, then you might want the frequency to be faster and then have it slow down as the signal tapers off. So again, this is kind of confusing. You've got your modulation frequency that we're going to use, and then these things control the variance in this. So if you have this set to say 1,000 hertz, then the LFO could make it oscillate between say 900 and 1100 hertz. Up here you've got controls for the depth of these two inputs. So the envelope follow, this determines essentially how much the variance in the envelope will change your modulation frequency, and then this selector indicates how much the depth of the low frequency oscillator changes the frequency of your oscillator. So if you put this all the way up, what that's going to do is you're going to have a greater range. So if you set your frequency to 1,000, then you put the LFO all the way up, that would mean that you have a greater range. So you might go from like 500 to 1,500 as opposed to 900 to 1,100. Same with the end follow. You've got those same settings over here on the output. What this does is this determines how much of an impact these have on the wet-dry selector. So you can actually kind of like oscillate between your wet and dry signals based on these same parameters. And then the last ones are these feedback and stereo width selectors. What those do is the feedback one works exactly the same way as the delay feedback worked in my video on delay, but that's how much signal we're feeding back into this effect. And then the stereo width selector determines how wide the effect is in the stereo plane, because remember, we're working with both left and right channels, so you can actually select how much depth you want between those channels in this effect as well. Down here you've got the rate, and what this is you can actually sync this to the tempo of your project if you want as well. So I think those are all the parameters of this ring shifter. So let's give it a shot. So again, this is what the signal sounds like clean, just a basic sine wave, pretty simple sound. And now we want to start messing around with the. Here, let me turn that up actually first, just so you can make sure you can hear it. So just a really clean signal. Now let's turn on the ring shifter, and first what I'm going to do is I'm going to basically use this as a tremolo. So this was the right portion, the right-hand portion of my picture, and you should just hear it kind of almost like gate your signal. So let's listen to that. Right, so it's kind of like someone's just tweaking the volume knob. You can mess around with the frequency there. Okay, let's see what the envelope follower does. So in this case, what you should hear is that now the rate should vary depending on the envelope of my signal. And this signal is just typical kind of like real-world sound, where you get, an ADSR type envelope and maybe sounds a little bit like plucking of a string or something like that. Okay, let's turn the sensitivity up. Okay, so there you could really hear it, right? It starts when I first attack, the frequency of the modulation is much higher than at the end. So it kind of slows down as the signal tapers off. Okay, and the same thing happens with the low frequency oscillator. It's just now it's fixed, right? So rather than following the envelope, the low frequency oscillator just does its thing. Oh, actually, all right. Okay, so now for the really cool stuff, and this is what this is kind of the culmination of the last two videos, and I know it's been a lot of build-up. This is where you get that really cool, like, techno-y sound. So let's see what happens when the frequency starts getting near or above the frequency of our input. Right? And if you look down here in the visual EQ, you can see that, so down here, you've only got this one peak. But now, when we get close, you should start to see the peak widen, and oh, we're starting to get the sidebands. So these are the convolution sidebands that we talked about in our picture. You see we got all these peaks now next to our main peak. And you can even broaden it and you get more and more sidebands. It just gets like freaking crazy, Sounds like straight out of a sci-fi video. So like just for fun, I kind of put this to a beat. I thought, I could kind of like mess around with this, but this is like, straight up 90s techno. Alright, so I can do that all day, but the takeaway is that we can really broaden your frequency response or your frequency spectrum of your instruments using techniques like ring modulation, what are we talking about? Modulation, ring modulation, and it's a cool technique to have in your repertoire. It's cool to understand on multiple different levels, and it's just a cool thing to know about. So that is amplitude and ring modulation. Man, why am I having so much trouble with this? Ring modulation, ring modulation, and I'm probably going to do another video on frequency modulation, which is another really interesting topic and does something similar, but in a slightly different way. So keep an eye out for that.